Like on the ones where there was only one part and I got it right, I still did it again. I don't know why.
Well,
Extra
okay.
practice, you know. That's good.
On number 15, the giant one, I missed 1 point. I forgot to put 3. So
Which
I had
one
to
was
redo
that one?
the entire thing.
Was that number 15?
Yeah.
I don't know what I got for number 15. I got half on that one. I completely messed up this first part because I put X's there, and I don't know why I put X's there. I really don't. I don't. That's great. Like, I'll look back on my work and wonder what the heck was I thinking when I did this. But then, you know, okay.
So, we've already gone over 1C and D, right?
Mm-hmm.
Okay. 2. We can do this. You have to take the derivative. Okay, it's right there. Never mind. Sorry.
I just put mine in a different order.
Yeah. And then.
Oh, you're on 8.
Yeah.
I was like, I did every single problem. I didn't get all of them wrong, but I did every single one.
Practice. Nice. Okay. This is good. Okay. I got something different.
So, what did you start this out with? Okay, you have.
I think I know what I did. I can simplify this further, right? Because this is technically x times negative root x plus, no, x squared plus x, so I can just put that on the bottom. And then it's this x over that, and then x's can cancel out of.
Well, when you take the derivative, well, that's a negative 1/2.
Mm-hmm.
So that would be 1 over that. And then you get to the point where you
I just
get to
kept it
multiply.
on the top, so I need
And then you'll eventually get to a point where it's x over square root of x squared plus 1 times the square root of x squared plus 1. And then that multiplies out.
like what multiplies out.
Because when you multiply 2 square roots that are the same, then you can just get rid of the square root. I actually felt pretty good about these corrections. I need as many points as I can get though.
Same. Same was x over x squared plus 1. Square that. Okay.
Yep.
Did you get 10?
Yep.
That's fine.
Well,
Okay, so you have.
It's similar. I mean, I have the 2x there from that.
Mm-hmm.
But then to get rid of the fractions, just multiply it by 2 over 2. So that would make that. The bottom is right.
Yeah, this would be negative.
Well, it should be an x right there, though. 5/2 of x.
Because, wait, I subtracted 5/2 x. That's where that came from. Minus the 2x.
Yeah, but then when it's on this side, you take out the factor like that. So that should be the x right there. Because you subtracted the 5/2 x, so it should be 5/2 x.
But this should be 5.
Well, this should have been 5 times. Like, that's already.
They weren't.
this come from?
Okay, we work on the front.
Okay, yeah. So wouldn't this just be the whole XY, and so you wouldn't need the 5XY outside?
I don't know how.
The only that I have different is I don't have this 5XY.
I got green lights about a contract. Are you okay with on contract? You look at it.
5 house.
It's the same contract. You just need to
Not the 5 house. And then I took the derivative of the inside because
and I still want to clarify because it's a net range where other words it's the same.
so then
I
I
mean, but it's the
um,
same. So Lori just sent me an email saying that the board trustees for theirs next, I think in a couple of weeks, and theirs is still signed by the board.
okay. You know what?
Our board meeting, Mr. Dobbs should sign.
And then
What I'm gonna do is just finish it up and it today, say it's ready for signatures, after it's all signed, send it back to me. Because their timeline is much stricter than
this
ours.
term to this side, so then you can factor out the dy by dx. You
And
just
then I will, get Mr. Dobbs.
I figured out 14.
Yeah.
I need it.
Okay.
I only missed one part of it. Like one teeny part.
What's the answer?
Amanda,
Yeah, just get.
rotate your camera down just a little bit.
Well, I got that mostly right on the actual test. I don't know how. I just had an extra x squared and just wanted to take that off. And then why on earth did I do that? Like how? What the heck?
More,
So take the derivative.
more.
You bring 2 in front and you would still have the x squared.
That's good, right about there.
That part done.
Where's the x?
You would take the 2x. So 2x is the derivative of the x squared, and you have to do the chain rule.
Okay.
So you put 2x in front of that,
Mm-hmm.
and then you keep the ex
Yeah.
squared. And then for tangent of 3x plus that, you would do. So then here, the secant squared, that is the derivative of just the tangent. So that would be tangent of 3x. I think somehow that cancels out.
Well, it would be, let's see, if you did the chain rule for just this part, if you're doing, not the chain rule, but the product rule, it would be the derivative of the first, so we would just have e to derivative, no, it would just be e to the x squared times the derivative of the second, so it would be
Didn't have it here, but I did it.
3.
Be that right there.
Yeah.
Do you have a paper clip?
Oh, that's second square, so that, yeah.
And, I mean, if you, I'll go with it, but that's not what I got. You can ask Miss Clarence, check and see.
1 minute. You're 1 minute.
I need your help. Hey, Brittany.
Can you get 14?
What did you get? Which one was it? What did you get for C? Let's see. Okay, just making sure. I felt that, I was like, that has to be off. That's weird. I
Yeah.
was thinking it had to be the
So
same
on the
slope as that.
original test, I only
Yeah.
got the slope. I never got the initial.
Yeah.
And it's just Brittany. What are you doing?
I feel that.
Oh,
Where's
Rachel?
Rachel? About this.
Rizzo's late for
I forgot.
You know,
Yeah.
that probably means I'm expecting around 70 on this test.
you mean another 20.
Brittany.
The third one in a row.
Oh, Brittany.
I mean, I'm still passing this and I don't know how.
Well, the good
Um,
told her.
Panda,
I haven't seen one in the class and she's just like,
since today is just a review day, I'm gonna let everyone have a few minutes at the start here, continue comparing their notes on their rework. So we'll actually we'll only start class with lecture, whatever here, and we'll get, say, 10 minutes or so to kind of get together.
Sounds good.
it's okay. I'm just gonna retake it at state and
Okay, Sammy, she said you're right.
These would be all changes.
That
was
way, I
just a
forgot,
straight-
you have to do a change,
This
so
would
you have to
be-
do the derivative of the inside
This would be
of the tangent, which would bring out a 3, which would change it to
And this one
whatever the heck it
the
has to
derivative
be.
tangent, just
Yeah.
find the derivative of that.
I hate
So the one thing you're here early, we get 10 minutes.
Me
of
too, I forgot a 3, so I had to do the whole thing again.
You know what's sad though? I did the entire test over, even the ones I did. After I finished, I was like, I didn't have to do those, did I? Nope. So I did
And
every
your
single one
reworks
again.
of the other thing are up there.
And in my luck, I'm gonna get one of the ones that I got right on the test, wrong on the corrections, and I'm not gonna get all the points.
Way to go.
You'll be okay, Sammy, you got it.
That is your copy?
But I may have missed a number or something. My luck is just, I have terrible luck. Terrible. I will never. Oh wait, no, my luck turned up this year. I won a watermelon in that raffle earlier this year. That is the first thing I've ever won in a raffle or contest or whatever. And then at the Halloween dance, I won the couples costume contest. Five times.
So you're working backwards.
If that doesn't say forever alone, I don't know what does.
I saw that on your story. And it's just like, man, I wish I could be at the Halloween dance, but I'm at work right now.
I can't imagine how pathetic I look. Like, there's all these couples that look really cute, and then I'm just there.
What were some of the costumes?
I don't know what they were, but they were cute.
I don't know what it was.
So that has to be.
And then our church had our fall festival and trunk or treat, so I wore my minion costume again. And a lot of the people at my church,
Did the
including
kids
adults,
come up to you?
well, some did, mainly because I was at a trunk with my friend, and they're like, can I have candy? I mean, yes.
Can I have candy?
So all the adults who saw it, they were like, so, I see you guys won the contest. And I said, yep, we're very proud. We both have certificates, and I feel like getting them
You
framed.
both got to
How sad is that?
Jamie, you have 2 certificates for yourself.
I do. Well, no, one's for my little minion. I was gonna throw him away after the dance, but now I feel like that'd just be really sad to keep his thing and not.
Just frame him and the certificate together.
Let's see, did I take a picture of it? I don't know if I took a picture of it. Oh, yes, I did.
Mini on.
It's how you spell, but it has mini in it, so I thought I'd emphasize the fact that it's a small mini. And I had a
Jamie,
fart
what
gun.
happened to the certificate?
Oh, we brought the cupcakes, and I didn't know there was grease on the tray, and when I was carrying it into the house, I just put it on it.
Aw.
And then that's, oh well. Yeah. We were very proud of that.
Just reason.
You guys should discuss together then.
And then halfway through the fall fest, I was just there helping with
Sammy,
food.
help me with 14.
Halfway through the fall fest, we ran out of food, so me and
Aw.
someone else had to run to Sam's Club really quick. And when we went there, I felt really awkward, looking like
Because
a
you were
minion.
dressed up.
But then there was another guy there wearing a yellow shirt. It wasn't neon, but a yellow shirt and overalls. And I don't think he was trying to be a minion, but I'll take what I can get. I was not alone.
Okay, so how'd you do it?
14?
I didn't even have my graded copy of the test, but I know I did terrible.
Did you
so
just
I
give
did
it
it
these
all.
ways?
But you got it.
Yeah, I know, I got it. But I wanted
So-
to
When you take the derivative of this, or like when you're doing derivatives, you would bring out the derivative of the exponent to the front because it's a chain rule. So you'd have the EX squared is the derivative of that whole thing because anything to the power of anything is still equal to the power of that.
Oh, okay.
And then you'd have to take the derivative of the actual exponent in x squared. That'd be 2x. So I knew that that was just going to be EX squared. And then as far as the secant squared goes, I know it was going to be the tangent of 3x because that's right here, you know, that. And then you'd have to do the chain rule for the 3x, I think, which would just be the 3 here. So
That's
that
why
would
you had a good
we
week.
just have a 3 there, which still makes sense in that context. And then
There he is. What's in the back? What is? Oh, tissues. Okay.
And then
Oh, there it is.
And then this part here would just be, since you're doing, I guess, the product rule, you would just take that and bring it down here.
All of
So it'd be the derivative of
No,
that
I mean like,
times that
like the ones
plus
Oh boy.
that
yeah, the ones
times
where we have to like,
that
graph.
Which just
for the derivative of that.
What are those called? Cause I wanna do more of those
Or have
because.
to graph them like 3 times.
Yeah.
And for showing my work,
Wait, so
I
where's
just
just the secant square?
the secant squared.
I'm just not gonna buy it.
No, I still don't buy it.
You never said anything about it. You just told me to take off the x.
That's the answer, and that's what I kept getting on the answer. But do this problem without integrals, and I didn't want to touch on that yet.
Yeah.
It was scary.
What did you get for 14?
Did you actually get?
I mean, okay.
Well, what's
See, here's the thing. I don't think it works with the question that it gave.
It does. Alex? Yeah. Okay.
I mean, I just think it's a poorly designed question.
It is.
Yeah.
The whole test was.
Yeah. What did I answer?
You got this?
Yeah.
This nice long.
I just used. And then I used my notes
So here's my
for
plan for
seven.
today.
You know, that was a smart idea.
I'm gonna work on the chem essay after we're ready for college. And
Can you help me? What's the last problem on the homework? Because I still don't
Which one?
understand what I'm doing. Revisions homework.
I think I have it. I don't know if I do. I'll say that I have it. Honestly, all of it makes sense to me.
You should help me.
Okay. Did you guys all?
They're so unnecessary.
Are you guys already taking it? I don't think
I have no idea.
Where'd the paperclip go?
What?
Or how to wash it.
You need to know how to wash it.
No, you just toss it in the
Oh my god, no.
bath. You have to take a bath with it. Ew.
Said that.
Please bring my grade up at least 20 points.
We should study for
Same with your shoes.
Attendance is just, I just made the first 100 out of 100.
I don't.
Take home.
Wait, where is that? Is that
so I can get a C.
I feel really good about this.
Oh, sweet.
Life is looking up.
Oh yeah, Brittany.
Yeah.
You know how much I got these shoes
Aw, I
for?
missed 1 point, Sammy.
Huh?
I missed
Aw.
1 point.
So you got
Because I didn't put my
35.
units on.
Oh,
Brittany!
Brittany!
Brittany. It's just 1 point.
It's okay.
Just one.
Just one.
Okay.
Oh, is that one?
But I put S equals seconds.
You're close. So close.
I was. It's okay.
Yeah.
You were right there. You got the right answer, and that's what that is.
Yeah, it's just writing from that.
Info that I don't understand.
Yeah, I felt. Brittany. You know how much I got these shoes for? This is the most pride I got. See this? This is lean. I told you about how you make lean, right? Like Sprite and Jolly Ranchers and cough syrup.
Oh. Never mind the
Yeah.
hospital.
Derivative over the derivative.
Why do people do this to themselves?
Because they get geeked off of it.
That's Vex over G of X. And it's like
Yeah, that's
prime
right.
Vex over G prime Vex.
That's true.
It's all in one.
That's all I'm good from.
It's been a long weekend.
It's been the same
And I
thing
didn't
as
even,
every other
I didn't even look at this
Hey,
until.
what are you getting for lunch?
Oh my god.
I don't know
I'm
yet,
really-
but I got money and I'm getting a paycheck this week.
Do you
So
wanna
I'm
get,
proud
like-
of myself because I didn't spend that much on the last paycheck.
You want to get like a nice savory burger today? You want to go to O'Callahan's?
I didn't want to.
I even made a fake test that I deemed that was
Yeah, no,
probably
no.
too easy.
Units.
Are you okay if I take a leave to work with Mason on the essay? Yeah. I don't want to.
Yeah.
I mean, it's due
That's right.
tomorrow.
Four
It's
letters.
due Thursday.
Four letters
It's due
cost
the
me like 100 point. Oh,
Yeah, Thursday.
If it was due tomorrow, I would freak out.
Really get a point. I'm scraping right now.
Doesn't seem that bad to me. I don't know. 600.
So I guess it's about time to start. So let me collect your extra credit test report. Does that?
Tonight's for cramming. Tomorrow's for the can work again.
Tomorrow, we can go to Oakland. Do we not have Rit Lake tomorrow?
Fixing the alternatives in already?
Yes.
Do we still have that? Yeah. But we still have that
Okay,
block.
so today we have, I guess, a review session, if you will, the test tomorrow. I've already put on this first board here and get our camera turned on it. Just a quick overview of what we've covered. So if you have questions, we'll talk about it. The review is that we covered section 3.1 in your text. And the first theorem stated that, in effect, stated that all extrema, what are extrema again? When we say extrema, what do we mean? Minimum, local, maximum. So all extrema we'll be looking at critical points, but not all critical points are extrema. You have a critical point that's not an extrema. Now, a vertical asymptote would be critical is your derivative doesn't exist there. That's how you find critical. And critical means the derivative doesn't exist or it's equal to 0.
Sure.
Then we have the Rolle's theorem versus mean value theorem. What goes on with those? What does Rolle's theorem say?
If you got two extrema, if you have an extrema, there's like a turning point in the middle or something.
Everyone hear all that?
Huh?
David, y'all hear that from Joe? He was
No.
he was telling us what the Rolle's theorem was out of memory. It was fantastic.
That's pretty awesome.
Yes. That we all ought to have that. So that if f(x) is continuous on the closed interval AB and differential on the open interval AB, then if take 0, you can conclude what? Now there's at least one place where the derivative is equal to 0. F prime of C has to be equal to 0 at least one place. Okay, well, what about the mean value theorem? I remember what that says? Yeah, slope of
There's somewhere that the tangent line equals sigma.
Yeah, mean value theorem says that the average rate of change has to equal the instantaneous rate of change at least one time. So if continuous and differentiable, those are the only two hypotheses, then the conclusion is that f prime on c is equal to the secant slope, f of b minus fa over b minus a. Okay, so you need to be able to know and apply and discuss the differences and similarities between Rolle's theorem and the value theorem. So the versus there is key. Okay. Then we went to section 3.6 on L'Hopital's rule and finding limits, and including alternate indeterminate forms where we had to convert those forms. Sometimes we use logarithm to an exponent that's variable on a variable that's a base. Then we use logarithm. Question? So we can do some examples. That's fine. And then the last bit we did was section 3.2 and 3.3. That's what we just got finished doing. And that's simply applying first order and second order analysis, like on that graph guideline I put on Moodle, to analyze a function and then sketch the graph from that information. So you can find where the intervals where the function is increasing and decreasing. You can find intervals where it's concave up and concave down. You can find local maximums, minimums, cusp, and inflection points and whatnot just by analyzing the function and its first and second derivatives. So you get a lot of detail about what the graph looks like simply by looking at the derivatives.
Sweet.
Okay, that's what we've covered. That's what will be on the test. In terms of the last two parts here, 3.2 and 3.3, that can take a good bit of time. So what you'll probably see on the test is only one or two functions where you have to do the whole thing. But then you'll probably have some other functions where I'll say, well, just do this, that whole graphing guideline, just do this part of that on this function. And then another function, do just that other part on that. So just pieces of the puzzle to test on each of those little pieces, and then now do the whole thing yourself. That,
yeah.
Okay, so that's question, Rachel.
So what you're saying is, like, on the two functions where you have to completely analyze it, there's not even going to be steps. There's not even going to be steps along the way. You just got to know the parts.
Right.
And then just go ham on it.
Yep.
Okay.
I mean, like I just described, you'll have before that, or somewhere on the test, functions where you have to do each piece. I won't tell you how to do it, but I'll tell you what I want you to do. So that's kind of lay out the steps for you right there.
It's 2 sheets. We get it. We get it.
Right?
Yes.
Okay. Although I think you probably ought to be able to do it without me having to lay out the steps. Honestly. So other questions about the test, or if you want to work some examples. Joe said he had a question on a homework problem or something he wanted to look at. So that's what our review is. If you have questions, we'll try to answer them. I go to section 3.6, number 43. All right. Number 43. Don't work. 7 minutes. Any suggestions anybody has they want to try?
Do L'Hopital on it.
No, we're gonna have to do something. Yeah. Let's see. If I first plug in a 0, cosine of 0 is 1, so 1 minus 1 makes a 0. And tangent of 0 is in fact 0. So that's it's indeterminate, and I could apply L'Hopital. Let's see what happens when we do that.
I knew that.
What does happen when you do that? What do you get derivative in the numerator? In the denominator, I'll agree with the denominator being secant squared of x, not the numerator.
Would it be positive sine of x?
Yes.
God, I'm sure.
I was really scared.
Watch, there's gonna be another 0. Oh my gosh.
If I get it wrong, it's on camera.
There's already a minus sign there, and the derivative of cosine is negative sign, so minus of minus makes positive. Okay, let's try again. If we plug in 0 here, what do we get? Sine of x is 0. Of 0. One over cosine. Cosine of 0 is 1. 1 over 1 makes 1.
I see that.
This makes it 0 over 1 squared, which is 0.
So we just did this.
That's okay. It's simple once you see it. It's not simple when before you see it. Okay.
Okay.
Other questions you want to go? Raising his hand up. So does Josh. Raise it. Go ahead.
Should I assume that we're not allowed to use calculators tomorrow?
Well, decided on that. That's a good question. I don't think you should need them for what we've been doing. Well, I might let you. I haven't decided. Let me look at it. I'll post something later on what my decision is. Question. Josh, what was your question?
I have a question on number 51 at 3.6.
3.651.
Brittany, we should trade hats. Sure, this one.
Hey, what's your question?
I was wondering if we could do it. I worded that really weird. Can we just do number 51?
We'll try to do it. I haven't tried that one. Sure. 51. X goes to 2 from the right of x minus 2 raised to the x squared minus 4.
Wow, this is warm. I'm gonna keep this. Is that 2 plus or?
Why? First question is, why do you think they put approach 2 from the right rather than just approach 2 in general? Why is that important? Because you're going to need logarithm, and you're raising something to a power. If you raise negative numbers to a power, you get some squidgy stuff happening. If you raise it to 1/2 power, negative to 1/2 power, you're taking the square root of negative. That's imaginary.
Oh, dang.
So I'm not sure how you define it for some other things. So we don't want to be raising negatives to power, so we'll keep it positive. And that will also allow us, when we have to use logarithms, to use logarithms. Okay, so if we attempt to plug in 2, we get 0 raised to the 0. 0 raised to the 0, which is indeterminate, but it's all. We need to rearrange it somehow. The game we set up is all the answer we're looking for, L, and then take the logarithm of both sides of the equation.
I remember this.
Oh no.
I remember this from the War of 1812.
What year was that?
1812.
So now that you created this new equation, apply logarithm properties.
I don't know my log properties.
I don't know either.
I'll pretend I know.
But now I've got, instead of a variable exponent with a variable base, which is always a problem, I now have a product. And that's more normal. So I check it again, let x get close to 2, and I get a 0 here. And the logarithm of getting close to 0 is getting close to negative infinity, which is still indeterminate and still alternate form. So I can't do anything with L'Hopital yet, but I can rearrange it so that I can do L'Hopital. Of the two factors in the product, pick one, eeny, meeny, and make it a division by the reciprocal. Typically, if I have a logarithm involved, I'm going to not do the reciprocal of the logarithm, but you certainly can.
Oh, that's a good.
Now, when I have a division by a reciprocal, I'll get the L'Hopital form that I'm looking for. Again, the numerator is going to get close to negative infinity, and the denominator, because you're getting the denominator of this fraction in the overall denominator, that denominator is getting close to 0, and 1 divided by close to 0 is going to infinity. So this is an indeterminate form that is, in fact, L'Hopital.
Yay.
You're going to apply L'Hopital to this.
Hospital. It's almost as good as high.
So when I do apply L'Hopital, what do I get?
Well, that's 1 over x minus 2. Yeah, I got him. Over.
Anything else you need to remember, even though, yeah.
Something you should
I
remember.
won't mark it wrong if you don't, but if this was not a 1x, it had been a 3x minus 2, then the thing a lot of people are going to forget is that you got to multiply by a chain rule there. You with me? It happens to be the chain rule is a 1 this time, but don't forget the chain rule is the point. Are we clear?
Oh,
Keep
yeah.
going. If you don't write it down, I'm not going to mark it wrong, but if you don't write it down and you needed it, then you're going to definitely get it wrong. Okay, what else?
Negative that
X squared
negative
minus
x
4
squared.
to the negative.
Do you want to change the exponent of the bottom thingy?
Sure, we can do that. We can visualize this in our mind as x squared minus 1 to x squared minus 4 to the minus 1.
Yeah.
What's the derivative of that?
Do I have to do the Hein rule for this?
X.
I don't know. What do you think?
I think
Yes.
yes.
Oh, okay. Why do you think yes?
Because there's a function on the inside and then there's an exponent on the outside too.
You have an inside function and outside function. So what does that mean?
A Hein rule? Hein.
Chain.
What does the chain rule give you on that?
Hang on a second.
Uh,
Yeah, it's pretty important for me.
Negative of x squared minus 4 to the negative 2.
Yes.
Times 2x.
Yes.
No.
Which I could rewrite, since I'm dealing with fractions, I can rewrite it as negative 2x over x squared minus 4 squared. So I can have over here negative 2x over x squared minus 4. And then now what?
You're gonna plug in 2 now?
Well, yeah, but you're still gonna get some issues, I think. Maybe not.
Maybe not.
Let's simplify it algebraically first.
Okay.
You're gonna get like, if you plug in 2, you're gonna get 1 over 0, which is infinity, and then down here you're gonna get 4 over 0, which is infinity. So you still get infinity over infinity, which is still L'Hopital. But I don't want to do L'Hopital if I don't have to. So let's do some algebra first. So I'm going to bring it over here now. Limit x goes to 2 from the right. Algebra, what do I get?
Why is there a marks?
Because it's not
Hang on, did he skip steps and stuff?
gonna be
Doesn't make a difference. If you get a negative sign in a fraction, it doesn't matter where it is. I just like it in the numerator because I just like it in the numerator. Next week. Okay. I think I can see some issues here by, let's see, if I plug in a 2, I'm going to get a 0 in the bottom and then a 0 on the top. That's still L'Hopital. What if we cancel them?
Oh, sweet. That's what I'll live for. Because it makes our lives easier. Unless you want to do the hospital again.
Don't have to cancel. You could do L'Hopital again. I mean, it doesn't matter to me.
Yeah, let's just cancel.
Okay, so what do we get if we cancel?
Let's make like the Clemens media and cancel. Got him. They need to destroy them. Just go with sledgehammer.
It's not me.
I know. Oh, hang on a second. If it's x squared plus 4. Oh, crap. You could write it as 2x squared plus 4. Dang. Huh.
What's this?
I'm just speculating.
Well, let's speculate an answer.
Okay. I'll tell you what, that's a difference of squares, which means you got that x plus 2 times x minus 2 game going on.
So then the x minus 2 cancel out.
Yeah. Difference of squares game never stop.
Now what it comes out to?
So it's just negative x plus 2 over 2x.
I mean, skipping a step or two, but as Raisen said, x squared minus 4 is difference of squares with factors as x plus 2, x minus 2. But it's the square of that, so I've got 2 factors of each of those. One of the x minus 2 factors gets canceled. And now what happens? Well, let's see, I get a negative of 4 squared times 0 over 4. So it's like a 0.
Oh, he plugged
Wait.
Yeah. I
Josh,
did
you
it.
can just L'Hopital again if you don't want to.
I did do it.
And you could have L'Hopital that got there too.
I did it.
We're done?
Yeah, sure. I'll take it.
Yeah. So this answer is equal to the log of the answer we were looking for.
Oh no.
Oh,
Yeah.
we were done.
Log of L equals 0, which means
I know. That's
L equals e to the 0, which is 1.
Wait,
Wait, can you zoom in on that, please?
Can you zoom in? Zoom. Keep going. Zoom.
What is that?
That's good.
Is that like a...
It means therefore.
No, I'm talking about that little
Yeah.
crescent shape after L.
That he eats
That's
a
an
0.
E.
Therefore.
L.
I just summarized what I learned from that by seeing that I had log of L equals 0.
I don't even understand this part.
Other questions?
Gosh. Yeah, Mr. Gaddis.
Yes.
So, you solved for the right side using L'Hopital and just manipulating it, but that 0 was only the natural log of L, right?
Say that one more time, you broke up?
What did you say?
Say it again.
So you found the 0. You found the 0, but that's just the natural log of L.
Correct.
So in that therefore statement, how did you implement that 0? Can you explain it a little, please?
Well, I have, starting back at the beginning, I had log of L is equal to all of these equal signs here along this side, all technically all equal to, log of L, log of L, so on. All of these equals, after the second step, all of them are log of L is equal to. So I just, since I hadn't been writing it down from back over there, I just summarized and said, therefore, because I have log of L equals 0 right here, and implies that L is equal to e to the 0.
Okay.
By definition of logarithm.
All right. Thank you.
Right. Okay. Other question, Joel? Yeah, for the graphing, okay.
I got a question about what.
You got one you want to ask specifically. So the question is about graphing for Maddie, and Justin said he's going to give us one. 3.3?
Yeah.
3.2. From 55 or 56, so you're on page 261. 55 or 56. Line chart, graph 5. Okay, challenge, okay. 56. For each sign chart, graph 5 in these exercises, sketch possible graphs of both F prime and F, each sign chart under unlabeled tick marks on locations where F prime of X is 0. The exercise where F prime of X does not exist for any tick marks labeled 0. Okay, so we've got -1 and 4 are both eating. We've got minus, plus, minus. We'll go here.
You know, 56, anything about my X.
Minus, plus, plus, is that right?
Yeah.
Right, so we're supposed to sketch a possible graph of F prime and of F.
What did it say, Bay?
How do we do that?
Does not exist.
Raise
Sketch a graph extension graph of
What section is this in?
3.2.
that's fine with that.
Thanks.
What's that gonna look like?
Well, do you want to draw the little lines? The -1 and 4?
Sure, that's a good idea. So something happens at -1, something happens at 4.
It's like a little sock sleeve hanging out.
And what happens between them?
I drew King Lear.
It says the function is negative to the left of this. I'm somehow below the axis to the left of -1, but then I'm above the axis over here somehow.
Yo, it's gonna get me geeked.
These are the values of f prime. So I'm trying to sketch f prime. This tells me something about the slopes on f, but I'm not talking about the graph of f yet. I'm talking about f prime. So f prime itself is negative, f prime itself is positive, and f prime itself is positive. So I know the location of the f prime graph to some extent. In between, at -1 and 4, it does not exist. How can you have a does not exist on this? F prime does not exist. Got an asymptote? Well, there's a cusp. There's a cusp on the original function that f prime does not exist. But what does the graph of f prime look like at a cusp is the question. No. So you're right. We're looking at f prime does not exist. So if the original function, if f had a cusp like that, then f prime would be does not exist. I agree. But how does the graph, if you had a cusp on f, how does the graph of f prime look like over here?
Yo, that's whack.
Like, the tangent lines are positive, more positive, infinity, and then infinity, or you might say negative infinity, and then negative and less negative, less negative. So your slopes are getting up close to infinity there, looks to me like. So if that was the case, I might have some kind of asymptote. Let's say that at -1 was this one. So looks like it's negative on one side, and positive on the other side.
Ooh.
So if I had, if this was f at, if that was f at -1, then I might have an f prime graph that looks like that, because the slopes, as I get closer to it, the slopes, well, actually, it's the upside down. I have that backwards. I apologize. Yeah. On a cusp like this, this might be a graph on f prime. So the slopes are getting more and more negative, and then they're getting from very positive to less positive.
Oh, that's cute.
That graph of f prime would match that cusp on f.
Okay.
Now what? We got a D and E at 4, and they both got to be positive.
Mm-hmm. It's a hole. Come on, it's a hole. It's a hole, right? If it's not going, could you say it's a hole?
Say again?
Can you say it's a hole?
A hole. It could be a jump. I mean,
It'd make me happy if it was a hole.
if there's a hole, well, yeah, that could be a hole. It could be a lot of things. It could even be an asymptote again, isn't it?
It can't be a jump.
I want this hole. Yes.
That's not a hole. That's what
I know this is what
You
Sammy
roasted me.
wanted. I knew this is what Sammy wanted, which is why I
That could
wanted.
be one. That's one example.
See, it's a W, Brady. Took an L. Took 2 L's, make a W.
I mean, it could be other things. Maybe instead of an asymptote, maybe like Rachel said, maybe there's a hole somehow. Maybe instead of a hole, maybe there's a jump.
There can be a jump. Why can't there be a jump?
Because you found the derivative.
Oh, wait, no, the
But the
original
derivative doesn't exist at that point.
Yeah.
Um,
That's deep.
okay. Okay.
That's deep. This got me mad geeked. Got me thinking like I'm back in Brownsville.
So how can my graph of f match this?
You speak it entirely.
Already got the -1, like
Baptist didn't say mad geek.
Brooklyn video.
there's -1 for f.
Oh.
Now, how does it match the rest of it?
Oh, it doesn't. I'll tell you what, it doesn't. Loop and pull.
Yeah, there would be another asymptote at 4.
Wait, are we on FX already?
And so this looks like it, it stays positive, but it kind of gets low positive. So maybe it kind of starts to almost flatten a little bit, but not quite, and then it goes on up to an asymptote. This stays very positive and comes down towards 0 as slopes. So maybe it's like this.
I remember this. Whew.
There's my f function from that.
No, it's not. It's going down.
But it's positive because it's above the x-axis.
No, we're talking about velocity, though. I don't think that's true, Mr. Gas.
No, we're talking about.
Yeah.
We're talking about f prime of x, still?
No.
We're talking about f of x?
Yes.
Then how can that right part, if it has a positive on the f prime of x?
Oh, you're right. That has a positive. Right, positive. Negative. Good catch. That's a negative slope. So let's make it again. What should it look like? Right, so you good catch.
Oh.
That's have a positive slope. So that's have a positive slope. You're right. Good catch.
Can you make it like a square root graph?
Yeah, maybe. How about a logarithm graph?
Oh, yeah. Yes. I like it.
Catch. Yes, it has to be positive. You're right. I had negative slope on it. You want to see that?
I'm geeked.
Okay. There's an example that satisfies.
Oh my gosh, really? Oh my chicken salad sandwich.
How would you do? Let's suppose this one was the same thing as there. How would you do this graph now if it has a jump discontinuity in it? If I was going to graph f over here.
Well, if you want to have a jump discount, you want to do a little absolute value thingy?
Yeah, that's probably something like that. Some kind of sudden change in slope.
Yeah.
I can have negative slope. I have to have positive slope. And then here, I got to have a less positive slope. And it suddenly jumps. Maybe we're at a say a 1 slope, and then suddenly it's a 3 slope. So we're just going to come to a kind of a corner there, and then we're going to start getting steeper.
Yeah, I'll take it.
Okay. Other question you want to go over? Everyone follow that. We're thinking there. So that is something you'll need to be able to do on the test. Is if I give you a sign chart without telling you the function. So even if you have a calculator, it's not going to help you. You have to be able to come up with a graph from the sign chart. There's not just one graph, but still you got to be able to make all the pieces fit. And when it says positive slope, make sure you get positive slope. Don't turn it upside down and make a negative slope like I did. What questions you want to go over? Anybody?
Mr. Gaddis.
Renzo. What?
Should we expect like another word problem too? Like an application and stuff?
Maybe.
Okay. Do you make these all the night before? Or do you have like a...
I start working on them like on the weekend, but I haven't finished it, so yeah, I'll finish it up today.
Okay.
I always kind of, look for what kind of questions I could use. Ask a question like that. Well, hey, that's a good idea. We should have a word problem.
Well, we had one last time too, so it's no different. I'm just callous to it.
We went over this, so let's have the opposite.
We should have.
Are we gonna have an easy question?
I told you in the review what's on there.
Yeah.
Oh, easy.
Yeah.
I would think some of it's going to be very easy, and I would think we might find a couple of them a little more challenging. That's good.
No.
Question, Sammy?
Can we do number 61 on 3.3? No.
Point 3, number 61. Oh my gosh.
I like it. Way to go, Sammy.
Wait, what is it?
Sammy, you're gonna get me geeked.
Corrections are,
Sammy.
that's a positive graph of F. Okay. Let's see what
At least we'll have it fresh in your mind.
Actually, this doesn't seem that bad.
I'm like,
Rizzo, shh.
It doesn't.
Don't tell him that.
It doesn't.
I'm the kind of
We've done
person
this
who goes
before.
through and I look at all
Wait, we've done
the
all
things
this
that
before.
look
It's just a
really
review.
complicated, and I'm like, okay, well, look at this. It looks pretty bad.
Yeah. Hit me with your best shot, baby.
Let's see. Negative, positive, negative. Then we've got one and positive, negative, negative, positive. And oh my gosh, oh my gosh, oh my gosh.
100 day I was.
Okay, first thing to say is the book takes the point of view that at the critical values, if they do not mark it, it's interpreted to be a zero value. If they mark it, they'll mark it as does not exist. So all the critical values up here are zeros. Clear?
Mm-hmm.
We can put that on a graph somehow. -3, 1, and 4. -3. And the graph itself is negative,
Yeah, I get it, Carson. Yeah.
positive, negative, positive. Okay, so that's what I know from the first one. Now, changing colors. F prime at -2, 1, and 3. So -2, 1, and 3. Okay, so what do we know? We have positive, negative, negative, positive. So that tells me something about the shape of the function. Instead of just, it's the sign of the f prime, but it's telling me that the function is either increasing or decreasing. So we have left of -2 in this area here is increasing. And then this area is decreasing. And then we continue to decrease. And then we have an increase. And we have 0, f prime is equal to 0 at those red marks. So it tells me the tangent line at those 3 marks, those 3 dotted lines, the tangent line is always a slope of 0. So we got to remember that. These are all 0 slopes here.
Pretty wise.
Then we do the f double prime. So -1, 1, and 2. -1, 1. Left of -1, it is concave down. -1 and 1. It's concave up. Between -1 and 2, it's concave down. And after 2, it's concave up. Every time you have a sign change, that's a point that exists, then you have an inflection point there. Okay, so let's see if we can connect the dots somehow. So it looks like we're increasing, but we're on the negative side of things here until you get there. Now we're positive. So we're increasing, and then we're negative and concave down. Negative, increase, concave down, cross the axis. At -2, we get a 0 slope, but we start decreasing concave down. Oh, I gotta stay positive. Let's go more steeply up. I gotta stay concave down. I gotta turn the concave up. And up. Then we got a zero slope. Then we got to be decreasing with concave down. Decreasing with concave down. Then we want to do concave up. Zero slope. And then concave up and increasing, go back across the axis. I don't know, that's something that works.
What about the x-intercept at 1, though?
Yeah, you're right, across it too soon. Right there.
I'm going to bust a capillary.
There you go. A little closer. Question? Yeah, that was a challenging one. You had to roll the piece. I think once to me it helps out. All those different dotted lines can be confusing unless they're color. So if you want to bring color pencils, you're welcome to do that on your test. I have students that bring them to class regularly because it helps them note take to keep things differentiated by color, because I try to use color for that purpose as well. Okay, what other questions do you have? Okay, so I guess we got 3 minutes. We're going to test tomorrow on 4 sections. One of the questions will be to discuss Rolle's theorem versus mean value theorem. The other questions will be to actually apply those theorems. And one question will be to discuss their similarities and differences. So there's your easy question. What's the similarities and differences of Rolle's theorem versus mean value theorem? And I guess this class can start 15 early, and Davidson can run 15 late as usual. I have a feeling we're not going to need all that extra time this time. I just have this hard a test as last time. The L'Hopital can be challenging, so we saw a couple L'Hopital problems that can take you several steps to get achieved. So. All right, well, we'll see you tomorrow.
What happened? Okay. Oh, yeah.
I have this much paper. It just lasts me the rest of the semester. I was like, yay, I'm going to use this for the rest of the semester and start out for the next semester. That didn't really disappoint myself. More notebooks for six.
It's like Jewish Halloween.
And you guys won. I thought it was this one. I thought that was, I think I threw it up there.
Yeah, Brittany, if we learn this, we win. And none of them are that hard either. Well, remember, he's going to give us an oblique asymptote. And once he gives us an oblique asymptote, you better make sure that your obliques are
Done. It's done. It's over.
right.
You failed.
Yeah, or you could just raise your power level to where you can take it. Do you want to get food now or later?
You're going to run out of gas and
I'll decide by the time I get downstairs.
I have clothes in my car. Oh, I should have.
awareness only. So she's passing out stress
Okay, the
balls.
place for your tomorrow.
That's all.
It's really good full time.
Yeah, let me get one.
We need one.
What is a stress ball?
We still have to figure that out. It's probably gonna be around lunchtime, but I brought one as a prototype to show everyone.
Nice.
Because it had to change last minute.
So guys, I changed the logo of our t-shirt, and I
What
just
is
want to let you know.
When is our next meeting?
Tomorrow.
It's gonna be November 11th, unless you want to meet before that.
Okay.
Here's what it looks like.
When is the competition we're
Since
going
the
to?
18th help me with it, then this is what I'm going with because I like it.
The 18th is so close though. Are we gonna be ready for this?
And then,
Okay, I'm hoping.
all right, here's what our logo is gonna look like. It's gonna be
Wait, when's the competition again?
the 18th.
Oh, crap.
BCCC math. Wait, no. I think I've decided to do.
Davy. Math. Stadium. Storm.
Storm. Stadium.
And then I have something like. Looks like this. And then it looks like a graph that goes. It starts here. And then it kind of goes
Ooh.
around.
really cool.
That's cool.
That is awesome.
I like
And
it.
then at the I can't decide if. And then I might put DCCC down there or something.
That is so cool.
cool.
I would have never thought about
What's
that.
gonna be on the other axis?
Nothing.
Success.
But that'll be the
It's not
front
on
of our
the
shirts.
That is so cool.
Because on the other ones it would just be this tiny little logo that I felt like needed more.
Okay.
I like that because we're the storm and it looks like a tornado.
Yeah.
That is
That's
so
what I was
cool.
thinking.
Disclaimer.
So I'm gonna get that done.
That's awesome.
That's Gil.
We're gonna be the coolest math club there.
Okay.
Also, I feel like getting hot chocolate.